Okay, now you know how to calculate stresses in Cartesian directions, sigma x, sigma y, and shear stress. And you also know how to calculate principal stresses, that's maximum stresses applied on the machine element, and also their direction. You can also calculate these maximum stresses and maximum shear stress using Mohr circle diagram. Mohr circle is a graphical visualization of all your stresses. So by only using stresses in horizontal direction and vertical direction and shear stress, you can calculate principal stresses, maximum shear stress. You can actually calculate stress at any direction on the machine element. So for Mohr circle, you need sigma x, you need sigma y, and you need shear stress. You always need 2 points to draw Mohr circle. For Mohr circle, you need 2 points. You need sigma x. First point will always be sigma x with shear stress, and the second point is sigma y and also shear stress. Okay, you need to be very careful with the signs because sigma x and sigma y, they both can be positive and they can be negative. Shear stress is the same, can be positive, can be negative. Normal stress, sigma, can be positive if it is tension, and it will be negative if normal stress is compression. So if I say machine element is subject to 150 megapascal compression stress, that is negative 150 because it is compression. If I say 200 tension, then that is positive 200. And the sign for shear stress is decided by the direction of rotation. If shear is trying to rotate the element clockwise, then it is positive. If shear is trying to rotate the element counterclockwise, then it is negative. So let's look at X face. This is X face here. This is X face. If I have shear stress in this direction, so this shear stress tends to rotate the element in clockwise direction. So that is positive in X face. To satisfy equilibrium, there must be same shear stress in Y face, but in opposite direction. So shear, tau xy, in Y face tends to rotate the element counterclockwise. So that must be negative stress. So if shear stress is positive in X, it must be negative in Y and vice versa. Okay? So using these 2 points, you can draw Mohr circle. In Mohr circle, a horizontal axis will always represent sigma or normal stress. Vertical axis will always represent shear stress. So above the horizontal line, shear is positive. Below horizontal line, shear is negative. Same with normal stress. Right hand side is positive, left hand side is negative. Okay, so for your 2 points, if shear stress was negative, just like this case, counterclockwise in X face, then it must be positive with Y face. Okay, so if I have stress status of sigma x positive, shear is negative, my first point will be here. Shear is counterclockwise in this case, so it is negative, and the point will be here. The other point, sigma y and shear is different sign, so it is positive or clockwise. These are the 2 points. Okay, now we need to identify the center. The center, if you connect these 2 points, the center is the intersection of this line with the horizontal line. Or it's simply, because this is sigma x here, This is sigma x, and this is the value of sigma y. The horizontal line represents sigma. So C, center line of the circle, is halfway between sigma x and sigma y. So if, for example, sigma x was 6 megapascal, sigma y is 4 megapascal, C will be between 6 and 4, that is 5 megapascal. Okay, so sigma x plus sigma y by 2. That's the center. Now to draw Mohr circle, starting from the center, the 2 points will represent the radius. So the radius of this circle is given by this formula. If you remember, this is actually the formula for your maximum shear. And that's obvious from Mohr circle, because if you see from here up to this extreme value for shear, this is radius, and that is maximum possible value for shear, and positive and negative also, because shear is positive or negative. Positive in one face, negative in the other face. Okay, what can also be calculated or found from Mohr circle is your principal stresses. Principal stresses is simply the intersection of the circumference of the circle with the horizontal line. So I have two intersections, sigma 1 and sigma 2. Okay, so you just read this value, and that will be your two non-zero principal stresses. So sigma 1 from Mohr circle, if you start from C, center, it is simply C plus radius, C plus R. Same with sigma 2. If you start from C or center, it will be C minus R. So these are the two principal stresses, the value of the two non-zero principal stresses. Okay, now their direction. To find the direction, you need value for phi. Okay, what we do, we always start from x face. This is the x face. From this point, sigma x and tau xy, we try to rotate x face to the horizontal line. So starting from this point, we go to the horizontal line in this direction. And the angle here is 2 phi p, or this one here. Okay, it's double the angle, double the angle of principal stresses. So phi is only half this value. Okay, so this is the direction of your principal stresses.